session. Okay, we are live now. Okay, so welcome to our last session for this semester. This is also, I believe, the last day of classes for this very interesting term that we've had. It's also Friday the 13th, so everyone be safe, please. Okay, so if we are dropped from this session within 5 minutes, or we can't get back within 5 minutes or so, please be aware that you can always check for the information in order the session to be posted on our Canvas site a little bit later today. Okay, so let's go ahead and get started. So again, we are going to go over some key information today that we've covered this week. You have the opportunity to ask some live questions. And then near the end, we'll have a Q&A, some announcements, and some reminders, and wrap things up for this particular term and see if you have any outstanding questions that we need to have addressed. So what we've been doing this week, we have been looking at cognitive neuroscience approach. We have done a lot this semester, starting out from the very beginning about how it is that we think about science and how science progresses, all the way to the philosophy of mind, and then start looking into how psychology seemed to emerge. At the same time, we talked about a variety of things of important interest to us. Let me pause real quickly. I forgot to do this. For those of you who are here, please just send me a little note saying that you're present to make sure that I can have the ability to identify you a little bit later. Okay, so the idea is that we see this cognitive neuroscience. It took us a while to get here, and this is one of the latest things that we focused on quite a bit in psychology, and we can trace its history all the way back to some extent, the discussions of the philosophy of the mind. The idea, again, we're looking here at cognitive neuroscience and looking at how technological advances have made it more likely for us to be able to study the brain. And of course, what we'll be doing as we go through these slides today, we'll be revisiting some of the concepts and ideas that we've touched on already dealing with philosophy of mind and our friend Rene Descartes. So, historical foundations. There have been many debates over many centuries as to where do mental experiences come from where do they hail, where do they rise from the heart or the brain. Okay, how can physical substance, the brain and body, give rise to our mental experiences? And this is to a large extent the whole thing that we started talking about in chapter 4, the mind-body problem again. How do we relate these two together? How do they integrate? How do they intertwine with one another? So Rene Descartes was one of the individuals who very concisely put together his idea of saying, from a dualism perspective, that the mind and body are separate substances. And he had proof initially of the existence of the mind with his famous "I think, therefore I am." The body, not so much. But the idea is that this is one of the ideas that Descartes proposed for us. And then we saw a little bit later the dual aspect or double aspect theory, where the mind and body are two levels of explanation of the same thing. I'm not that much into physics, but I know, for example, that sometimes certain substances can be seen to behave like a wave, and sometimes the same substance can behave like a particle. The idea is that we have this certain type of duality, that the same substance, just different aspects of that substance. And then we have the notion of reductionism, where that is the belief that eventually the mind can be explained solely in terms of the physical, the biological theory. So all these things, these issues are still relevant to modern cognitive neuroscience. Although they happened hundreds of years ago, they're still legitimate things to debate and to talk about with many of the ideas in modern cognitive neuroscience. So looking a little bit more and deeper at the historical foundations, from the very beginning, anatomists believe that the ventricles of the brain, as we can see in the very top graph here, where the ventricles seem to be huge, the ventricles of the brain were very important, okay? The cortex was often schematically drawn, as we see here, misrepresented like intestines in the bottom left. They look more like guts. Until later, where we see Gall and Spruceheim, where they provide a little bit more accurate depiction of what the brain does look like. So we can imagine the differences between these early renderings of what the brain may look like compared to what we're capable of doing now when it comes to imaging technologies and things of that nature with MRIs, fMRIs, PET scans, and so on. But the idea was trying to at least to understand what the structure of the brain looks like so that we can start to piece together what this thing is and how it has an impact on our life. Now, one of the early incarnations of trying to do this was with Franz Joseph Gall, and he developed, quote, science, unquote, of phrenology. Okay, phrenology was one of those things that is considered a pseudoscience today, where they would be able to look at someone's skull and look at the bumps and indentations of the skull. The belief was the brain is somewhat like a muscle, and if you have a sort of a bump in a certain area, maybe that means that that particular area of the brain is more strong than other parts of the brain. And so what they believed was this, that different parts of the cortex serve different functions, that differences in personality traits manifest in differences in cortical size and bumps on the skull. And what they did by doing this, they divided a crude division of psychological traits. So they would say this represents this trait on this part of the skull and this on this other part of the skull, saying that the brain underneath that skull was responsible for certain types of traits or certain types of functions. This was just someone's thoughts that came up with all this type of stuff, using their own version of logic to try to understand how the brain functions. Now, it should be noted that although phrenology is discredited, the notion that different regions of the brain serve different functions has stood the test of time. So they were right in some ways, but not in others. Okay, this idea that different regions of the brain serve different functions has become known as functional specialization, that areas have a functional specialization. Modern cognitive neuroscience uses empirical methods to ascertain different functions. This is something that they did not do in phrenology. So here we do not assume that each region has one function or each function has a discrete location like phrenology did, but it does assume some degree of specialization of neurons in particular regions. So the neurons, the basic building blocks of our nervous system, that it's the neurons in these particular areas or regions of the brain that may have some sort of specialization. So these are functionally specialized to carry out certain types of functions. And that's where functional specialization is. And it's the same thing, but it's without the phrenology overtones here. So again, phrenology did hit on an idea that did have some merit to it, and it was picked up. So this is where we are now, assuming this specialization of neurons in particular regions of the brain. Now, how did they identify some of these particular regions of the brain? Oftentimes, a long time ago, in the history of science as well as psychology, when something went wrong with a person, when they did not behave the same way that other, quote, normal people behaved, particularly in areas dealing with their behavior or emotionality or their observable thinking process. When those individuals died, they would then get their body, crack their skull, open up their brain, and then compare that person's brain who had the odd and unusual behaviors or lack of capabilities in certain areas with another person's brain they have access to see how they differ. And through this comparative of brains of these dead humans, they were able to try to point out areas of the brain that might be responsible for certain things. So a patient with left frontal lesion, one of the classic ones name is Tan, who could not speak, but had otherwise good cognitive ability, so he just could not produce speech, and otherwise he was, smart enough, suggested a specialized language faculty in the brain. So this was the identification potentially of an area of the brain that was responsible for a certain faculty, a certain type of function. And here it would be the function of being able to speak. So that's how they were able to start to hone in on certain areas of the brain and their functionality. We see the same thing happening here with Wernicke. So the first one was Broca, and this is now Wernicke. He later observed a patient with poor speech comprehension, but good production. So this person could not understand the spoken word, could not comprehend it, but could speak okay. All right. So what this does here, it suggests at least two language faculties, two language functions within the brain. One for comprehension, which is Wernicke, and one for production, which was for Broca, that can be independently affected by brain damage. So one could have an issue with Wernicke's area, but not with Broca, and vice versa. And the faculties would be seen for one and not the other. So this demonstrated that, yeah, there seems to be some sort of localization going on here. So note that the faculties were inferred here from empirical observation. So they knew what the person was capable of or not capable of. And then they were able to compare it with people who were capable of those functions to see how the brains were different. I mean, it is empirical observation at its finest. Now, obviously, everyone they're observing, they're dead already, but that's beside the point. They were able to understand how things are functioning here. So this inference can be made without necessarily knowing where in the brain they are located. And this is the approach that later became known as cognitive neuropsychology. So we see from the very beginning of trying to understand what the brain even looks like, how it functions, and figuring out how it functions and what it can do by looking at people who were damaged in some way. That's sort of like the history of how we got to where we are. Now, not everyone is in agreement with all the reliance on all the imaging technology out there. Some people refer to a lot of the things that are being done today in modern cognitive neuroscience as the new phrenology. Okay, Otto has argued that functional imaging is nothing but that, new phrenology. So Otto's new book that he wrote some time ago, is new then, was called The New Phrenology. It's an iconoclastic attack on even the possibility of the localization of cognitive function in the brain. Okay, he criticized attempts from lastly on up to today, and Udall is particularly scathing about current studies of imaging the human brain. So not everyone is in total agreement with the use of this imaging technology, so to speak, to try to understand functionality. Some people believe, or at least Udall here is very strong about it, that it cannot be done the way that we are imagining. And he's sort of warning us that this could be no different than phrenology, is what his perspective is here. So how did we get here? As I sort of alluded to earlier, the return to the brain, we have this cognitive neuroscience was aided quite a bit by these technological advancements and other things that were going on too. So let's understand too and remember that psychology is not happening and science is not happening in a bubble. Everything else doesn't stop when we are getting our science on or getting our psychology on. Things are still out there happening in the world. So remember, just before the 60s and 70s, cognitive mental processes was not something that we talked about that much in a lot of psychological circles in America. Okay, this was during the time of behaviorism. And it wasn't until some of the behaviors we have, like McDougall and then Tolman later, started to open the door, as did Abraham Maslow and Carl Rogers, even when they started the humanistic movement of psychology as a reaction to the behaviorists and the Freudians, that they started becoming interested again in mental processes. And then the technology on top of that aided it greatly. So we saw in the 70s structural imaging methods. In the 80s, we saw the PET scans, and we saw that they adapted models of cognition developed by psychologists by using these PET scans. We saw the TMS used as opposed to Penfield's earlier studies, which were much more invasive, and these were less invasive. And then 1990s, we saw the level of oxygen in blood used as a measure of cognitive function. The idea is that when you're working on a problem mentally, the parts of your brain that are working for that on that particular problem are going to be using more oxygen and more energy. And so this is the basis behind fMRIs. They're able to identify what parts of the brain that you can utilize when you are working on a particular function when it comes to working on a problem in your environment and within your space, so to speak. So all these things led to become tools of cognitive neuroscience and the development of science as we know it there. So that gives us a long background into how and why it happened to a degree and where we are now. Now we come to something a little bit more in the nitty gritty, and this is modularity. There are going to be two ideas that we're going to be talking about now as we start to wrap things up: modularity and embodied cognition. So we start off with modularity. Jerry Fodor. Fodor argues that certain psychological processes are self-contained or modular. Self-contained, modular, compartmentalized. This is in contrast to what we see modern cognitive positions are. And these modern cognitive positions are as follows: that psychological processes, nearly all of them, are somehow interconnected and freely exchange information. So we have this neural net of information, neural net of information. I apologize. I was telling somebody to get me some coffee here. And she could not understand me. Okay, apologies. All right, so we have this neural net of information, and they're all networked and connected. So that's the modern cognitivist perspective here. And what Fodor is saying is that there are going to be certain processes are not going to be connected to this big net of information. They're going to be self-contained. So Fodor proposes a three-tiered cognitive system. The first level you're going to be quite familiar with, and that's going to be the level of the system of the transducer level, where we transform environmental signals into a form that can be used by the cognizing organism, by the thinking organism, and this is called transduction. So we have environmental stimuli, and then we have our specialized sensory receptor cells in our body. For example, our rods and cones and the retinas of our eyeballs. And they're designed to pick up the signals or the light from our environment and then turn it from electromagnetic waves into neural impulses that we can then process. So the information can be taken through the optic nerve to the thalamus, and from the thalamus to the occipital lobe, where we can find out what it is that we're looking at. So that is the idea of transduction. So that's the first level. The second level, the input systems level, performs basic recognition and description functions. This is the level in Fodor's model where the input systems are modular, that they can be self-contained, not connecting to the larger network, okay, of the mind, so to speak. The third, we'll talk more about that in a second. And the third level of the system, the higher level cognitive functions, performs complex operations on the output of the input systems. An example here of the higher level process is analogous thinking, where you come up with an analogies, okay, where you're analogizing two things here and say, this is similar to this. So you're using one idea that could be somewhat abstract to explain or describe another idea that have some sort of similarity to it. So what FODAR is suggesting is that we have this transducer level, and then we have this higher functioning level, which we do the higher power thinking. But in the middle, the second level is where we have this modularity, where things can be self-contained, compartmentalized. Now, why would that be? One of the things I think in one of the videos that's available to you, this unit, is the idea that things can work much more efficiently and effectively when things are self-contained. They only have to work with themselves, work with the data they require and need in order to process information. I think they use computer terminology to some degree when it comes to that type of thing, where you have these segmented codes or segmented programs that can function really quickly and do what they need to do on their own and not have to go check everything else. And that is one of the ideas that they propose that's going on as well. So with modularity, FODAR holds that the input systems are modular and that higher level cognitive processes are non-modular. This means that all of the information necessary for performing their task of recognition and description is contained within the input systems. For example, object perception might be modular, in which case the object perception module need not reference or look to for information the language module, the music module, or the mathematics module in order to perform its operations. It can mind its own business. It stays put within its own module. It does not go and try to get information from the other modules. In contrast, higher level processes have access to all the information contained within the cognitive system when performing a given operation. So FODAR provides the example of scientific reasoning, a higher level cognitive process. Potentially, when solving a scientific problem, the scientist can reference any knowledge that he or she has about the world to help in solving this problem. As such, if necessary, knowledge about botany can be referenced in order to understand problems in mathematics. That's what it comes down to. So when it comes to modularity, this self-containment does have its advantages because it does allow us to work more readily, more speedily through systems, makes us much more efficient, okay? There are some downsides to it potentially, but that's what we're talking about, is that these things are very powerful, and that's why we have them. The suggestion is in one of the videos is that we evolved into this because it makes sense for us to operate in this manner because of greater levels of efficiency. So these are some of the properties of these modular systems. They are domain specific. They operate on and have a computational architecture that is unique to certain stimuli. So domain-specific stimuli. This stimuli, there's a module for it. If it's a different type of stimuli, that module doesn't work for it. 2, their operations is mandatory. Okay, we must use the module. Or they are cognitively impenetrable. Cognitively impenetrable, meaning that beliefs, whatever you believe at the time, what your beliefs cannot affect the operations of modules. We cannot help seeing or hearing the world in a certain way. That's a very powerful thing right there. That the operations are mandatory and they're cognitively impenetrable, that we cannot help see, hear the world in a certain way. 3, modules are fast. Modular processes are among the fastest psychological processes. This is because modules are self-contained and need not spend time referencing information outside of the module to complete their task. Everything they need to do to complete their task is within their module, at easy hands reach, so to speak. They don't need to go beyond their module to get any other information. Only within their realm of influence there that they need to get their information. 4, modules are informationally encapsulated. They need not reference any other psychological systems in order to perform their operations. And 5, modules have shallow outputs. The output of modules is very basic. More complex representations follow after higher level computations. So when we use the module, it gives us a simple understanding, a simple recognition. Okay, it gives us that simple recognition or description of something, some stimuli that we've processed. It doesn't give us some higher level processing. That would be for another level of the last tier, the third tier of the cognitive system, as Fodor saw it. So what does this mean? Well, it means the following. Information encapsulation example here. We have all seen this illusion before, and we know the trick behind it is that these lines are the same size, okay? Even when we know it's an illusion, even when we know it, we are still susceptible to the illusion. It is informationally encapsulated, okay? And why does this happen? Okay, again, evolutionarily, it would suggest that it happens because this was just a more efficient when organized as a series of modules. Because to be simply put, we're able to get things done more readily, more smoothly, as opposed to operating with everything being connected to everything else, as is the belief currently with many modern cognitive systems. So again, the key idea here is their operation is mandatory, or they are cognitively impenetrable. Beliefs cannot affect the operations of the modules. We cannot help seeing or hearing the world in a certain way. I'm going to pause there and see if there are any questions or comments. You can speak up or send me a chat message as I take a few sips of coffee. Okay, everyone seems to be good. All right. So that is modules information encapsulation. Now, the next idea is one of embodied cognition. Cognition is embodied when it is deeply dependent upon features of the physical body of an agent. That is, when aspects of the agent's body beyond the brain play a significant causal and physical constitutive role in cognitive processing. Now, let's be honest, everything that we've talked about so far this semester, and even when you came into this class from the very first day, most oftentimes we all think about where it is that we think, and it always resides in the brain. In fact, that's where we usually believe at some level that's where the mind is, this thing that we've been talking about but can't really put our hand or finger on. I can't really objectively see that the mind is there somewhere. Okay, mind / consciousness, okay, tied to the brain somehow. Again, right back to the mind body problem. So in general, dominant views in the philosophy of mind and cognitive science have considered the body as peripheral to understanding the nature of mind and cognition. The idea is the body simply is there. It is simply a place that houses the brain, the mind, okay? It simply houses the mind, but it's the mind that is the thing that matters the most. So that's the way it is currently and has been seen for some time. Proponents of embodied cognitive science views this as a serious mistake, that we are ignoring something which is of vital importance to understanding cognition. Sometimes the nature of the dependency of cognition on the body is quite unexpected and suggests new ways of conceptualizing and exploring the mechanics of cognitive processing. So one of the ideas that I'll sort of walk you through here in a way is remember those individuals, and I'm probably one of them, that when they are talking or when lecturing, they must move. They must move their hands. They must pace back and forth. Now, you guys have not experienced that because of what's been going on the last year or so. But in a face-to-face class, given the opportunity, I'll be pacing back and forth like crazy. My hands will be gesticulating. In fact, my hands are gesticulating now. Okay, it helps me to process. It helps me to communicate. So that's something too that we all probably have seen others or we may do ourselves, that we do certain things that seemingly help us to think things through. Okay. So embodied cognitive science encompasses a loose knit family of research programs in the cognitive sciences that often share a commitment to critiquing and even replacing traditional approaches to cognition and cognitive processing. Relatively recent work on embodiment of cognition provides much food for thought for empirically informed philosophers of mind. This is in part because of the rich range of phenomena that embodied cognitive science has studied. But it's also part of those phenomena are often thought to challenge dominant views of the mind. So we got to understand here, this is somewhat of a minority perspective in a way, but the idea is that there is some probably meat to it, such as such things as the computational and representational theories of mind at the heart of traditional cognitive science. This is something that this sort of pokes at to a degree. And they have sometimes been taken to undermine standard positions in the philosophy of mind, such as the idea that the mind is identical to or even realized in the brain. So the ideas represented by embodied cognition are somewhat heretical in a way, in that it does go against many of the commonly held beliefs that we currently have. Here are a couple of examples of embodied cognition. So these four examples of phenomena that have motivated embodied cognitive science. Okay, we typically gesture when we speak to one another. And gesturing facilitates not just communication, but language processing itself, as I was saying earlier. So we do see that there's evidence for that. Vision is often action guiding, and bodily movement and the feedback it generates are more tightly integrated into at least some visual processing than has been anticipated by traditional models of vision. So, so bodily movement. Remember, I think it was Berkeley's theory of vision, I think, where he talked about having multiple modalities. Okay, as you're walking and judging distance, the crunch of the leaves under your feet, all of this comes into play. And so that idea seems to mirror this one as well. And then there are the neurons, the mirror neurons, that fire not only when we undertake an action, but do so when we observe others undertake the same actions. And so we've seen this mirror neurons before in other classes as well, I'm sure, where these mirror neurons, sort of like these imitation neurons out here, we can see people do actions and then they fire when they're doing that type of action. And then four, we're often able to perform cognitive tasks such as remembering more effectively by using our bodies and even parts of our surrounding environments to offload storage and simplify the nature of cognitive processing. If you really think about it, if we recall from previous classes, I don't know if we talked about it here in this class, but the idea of context dependent learning or context dependent memory, where when you're in the same room where you learn some material, being in the same room helps you to recall that information. Or state dependent or context dependent learning too. There's one classic study I recall where a group was learned a list of words either on land or underwater. Okay, some learned it on learned the list on land, some learned it underwater, and they were able to recall more items from that list when they were in the same context they were in when they actually learned the material. So we see many indications out there that things beyond the brain, okay, may be aiding us in some way to recall information or to process cognitive data. So that's where we are there. So that's embodied cognition examples. So where are we now? So embodied cognition, where are we now? Although the phenomena that we just covered, 1 through 4, motivate embodied cognitive science, appealing to such phenomena to arrive at more substantive conclusions that have been drawn, the meat of it is this. Because of their requisite argumentation, typically appeals to other concepts central to the work, empirically informed philosophy of mind and cognitive science itself, such as modularity and nativism. Debate over embodied cognition has become a very hot topic in cognitive science in the recent years. Because I'll leave it with this statement here. Embodied cognition and the idea of cognition being embodied, it goes against the commonly held beliefs or paradigms of our current science in this area. So if we think about what we've talked about paradigms in the past, paradigms are powerful, they're strong, they are reluctant to change because it takes time for there to be enough anomalous information to really change things. So we see that this is sort of like a minority perspective right now. It may be growing in force, but somewhat of a minority perspective because it does do something that is somewhat against the paradigm. Are there any questions so far before we go wrap things up with this last slide?
Actually, do you feel like this will change?
I believe the more that we learn that, I mean, personally, I'm going to be somewhat biased because I personally experience it every time I'm lecturing. I'm talking right now to you and my hands are moving like crazy. Okay. And I know when I have been asked by students as a test on me to not walk when I'm lecturing or not to use my hands when I'm lecturing, it's very difficult for me to process. So it could be some sort of conditioning, but it will take time. Again, we do have this strong paradigm already in place. And again, as we've learned, paradigms can take a while to shift. Okay, so it may be some time, or it may require some new technology or a new perspective on things from a young student yet to come out on their own to really enlighten us to such a degree that we believe it more. But it probably will take some time before it can do that. Anyone else? Okay, so that gives us the cherry on top, so to speak, for the particular course of philosophy of the mind, of history and systems, covering the key ideas of science progression, philosophy of the mind, and psychology. So let's look at just wrapping a few logistical things up here for us. So module 5, which is the last module for this particular course, the exam has been open for a day or two. I think a couple of you may have already taken it. It covers only chapters 16, 17, and 18, module 5, and that will serve as your final exam. But there are other things I want to make sure that we understand too. First, just to remind you, you may have received some sort of information about a course evaluation. Please, if you have not done that yet, please complete the course evaluation for this particular course. The final exam is open. It will remain open until November 16th, 11:59 p.m. So you guys can go ahead and get it out of the way before the full finals exam we can take effect, which is going to be the week of November 16th, I understand. Now, during the week of November 16th, I usually have that as sort of a grace period as I'm trying to catch up on a few things. And by the way, all your papers have been graded. I just have not had an opportunity to post them, particularly the last 3 to 4 days I've been out sort of sick here. So the week of November 16th is going to be sort of like a grace period that I'll be looking to see if there are any outstanding papers that were put in or posted a little bit later. And if I have the opportunity and time, I will go ahead and grade those types of things to give you credit for them. Again, the senior psychology assessment bonus activity, that is up there as well. I think some people have already taken that, and that will be used for bonus points for you as well. Again, just a reminder, essay 5 and 6 were no longer required for the course. And the other bonus activities, just to remind you what they are, there's one that I find quite enlightening. It's based on the last discussion forum that you guys had, which was the one about Adam, the synthetic person. And this one's sort of a follow-up to it. It's from a TV show that some of you may be familiar with called Battlestar Galactica. Has a scene there where you have a synthetic person talking to a human person and looking at that dynamics and answering some questions about that. This ties into a few things that I always usually talk about during my classes, particularly my face-to-face ones, dealing with what happens if we are able to break that artificial intelligence code and are able to develop things that can really think mentally. And then what if we have the audacity to put those thinking minds into bodies that look very much similar to our own or are nearly indistinguishable? That brings up a lot of questions dealing with ethics and things of that nature. So that's what that bonus discussion forum is about, if you haven't seen it yet. And then there's another optional exam that I have posted. I think I posted it maybe a day or so ago doing one of my better spells that I was able to get up and get some work done. And this optional exam, I think it's like 25 items or so. It covers the basic topics that were covered for your essay. So the list of essays that are listed on your Canvas site basically tells you the types of topics that are going to be asked about during that particular exam. Again, it's an optional exam. You can take it if you want, and it won't, any of these optional assignments will not count against you. They can only help you. Okay, are there any comments or questions at this time? I'm going to take
Yes,
that. Okay, go ahead.
I have one.
Okay.
As far as the last module, the last one where we have to talk about what we liked about the course or the different things in the course, how many classmates do we have to respond to on that one?
If there are no specific instructions, probably not many at all or none.
Okay.
Okay, just give me what your thoughts are, and I'll use that to try to help me figure out how to improve the course for next term.
Okay.
Okay, then.
Thank you.
All right. Anyone else? Okay, it's been a blast. I'll see you guys later, hopefully on the other side of this pandemic. If not, you guys take care, okay? And good luck with your exams and other classes as well. Bye-bye.